Hi everybody, we're back for day 2 of Unit 8. Yeah, Unit 8 on exponents and radicals. So today we're going to talk about simplifying exponents. Some of the stuff you saw in class the other day. And we're just going to go in and start practicing. So yeah, let's go ahead and get started. Oh, there it is. Okay, so to simplify exponential expressions, which are basically expressions with lots of exponents in them, we must follow the order of operations and work from the inside out. So we're not really following GEMDAS, but we're following the same thing. We're going to work inside out. Okay? So here's an example. We have h squared times h to the 7 to the 0. 0? 0. Okay? This one really only has one way. So you want to work with the innermost here. So you want to work with this part first, because you need to know what you're actually multiplying with the h squared in order to apply that law to it. So here, we go ahead and simplify this. This is a power of power, so you're going to multiply the 7 and the 0. Oh, I just wrote it out a little differently. So 7 times 0 gives you 0. So now you can go ahead and add these two together, or you could even change, where'd it go? Yeah, you can change it to a 1. So h squared times 1 is just h squared, or you can go ahead and add these together, getting you h squared plus 0 gives you h squared. So there's different ways to take it, but the common thing is that you want to work from the innermost and then out. Okay? So here is another one. You're going to try this one on your own. You're just going to simplify it. So you got two parentheses going on here, so you want to take care of those first. Okay? Go ahead and try this on your own. Pause the video. When you come back, I will show you some of the different methods that I think you could possibly do here, okay? Okay, welcome back. Hopefully you weren't too scared of it and you tried. So here's what I could do. I just put a multiplication symbol in between, so I remembered that it's multiplying. And then I went ahead and actually distributed this 7 to both of it, because it's the power of a product. So I need that 7 applied to both the m and the n. So I did it like this. I just put it in parentheses so it looked a little bit more familiar to me. Now that I have this, I actually have a power of a power 3 different times. So I'm going to go ahead and take care of those 3 and multiply the exponents together. So now I have m to the 28 times n to the 21st times m to the 28. Now I can just go ahead and look at these. They have same base and they're being multiplied together. So I can do what to the exponents? I can add them together. So I end up getting m to the 22nd plus 22nd, or not 22nd, 28th plus 28th times n to the 21st, which comes out to be m to the 56th times n to the 21st. Okay? And it's just about taking it slow and doing one step at a time, okay? We'll be definitely doing more practice with this in class, okay? Alright, so here's another example. We have to simplify it, but we can't have any negative exponents, alright? So, there's lots of different things you can see. You see we have a negative exponent here, we have a negative exponent here, we actually have a power of product here. Whichever one you want to tackle first is okay. You could get rid of this negative exponent first by flipping it up. You could get rid of this one by flipping it down. You could tackle this one. I think this one I actually tackled. Yeah, I went and distributed out that 3 first. Okay? But then I have my negative exponent here that actually belongs down here. And I have this one. Where'd it go? This one that actually belongs up here. So I went and flipped my negative exponents next. So now I have negative 3 times m to the 3rd times n to the 3rd times p to the 8th over k to the 3rd. And I actually can't simplify anything anymore because I don't have the same bases for the exponents, and there's nothing with the negative 3, so that's my final answer. Okay? The last one is this one to try on your own. We kind of already did this one in class. What's missing? Find the missing exponent. What belongs in that box that will make it true? Okay? So try that. When you come back, we'll have the answer. Okay? So, we know that it's a power of a power. So these two numbers are getting multiplied together to create negative 12. So what gets multiplied with 3 to make negative 12? Well, not 4. Negative 4, right? So it would be, oh, that's basically what I just talked you through. Yeah, I don't know why it has negative. These should all be negatives. Weird. Negative 12. Negative 12. Negative 4. There we go. So what's in that missing box should be negative 4. Okay? That's basically it for exponents. That's the majority of stuff you're going to see is like when you have multiple laws you have to put in place and kind of take your time and go through each one at a time. Or like finding what's missing and stuff like that. Working backwards. Okay? That's really all I have. We're going to do lots more practice with the different kinds, like the bigger kind of exponent problems. We have a couple of activities to do in class. And don't forget though, or if you're an orange day, you are having a quiz on exponents on the 22nd. And if you're a white day, you're having it on the 23rd. So that's next week. Wednesday and Thursday is when we're having a quiz on exponents. And we've actually covered everything on exponents. So it's going to cover all this. Not only the laws, but simplifying them using the laws. Okay? Remember, if you have any questions, please write them down. We'll go over them next class. And we'll do lots more practice. Okay? I will see you next time. Bye!